that we just looked at, here's one with some non-lactose fermenting colonies on it. So we're going to subculture these two biochemicals. All right, you can pass up the other one for me. We are subculturing this to biochemicals, and we start with a screen. This Kliegler and urea, we start with these. All right? Because these will give us an idea of maybe what to expect. If you pass that chart, I'll show you something on this chart right here. One right in front of you. If you notice that what we're saying here is that rectal swab into gram-negative broth, the day one into McConkey, Shigella, just what I told you. Now on the day two, you're going to look for non-lactose fermenting colonies, and you're going to subculture those to your Kliegler and your urea. All right? Now the Kliegler and urea, depending on what we find, you do further work. Now if we get a Kliegler urea looking like this, it has an alkaline slant, it has H2S, which is a blackening, and it has some gas pushing up the media, and it's urea negative. This is suggestive of salmonella. All right?
Could you repeat the three things?
H2S, the blackening of the butt of the Kliegler, along with an alkaline slant that is pink, along with gas here, that is along with urea negative. This is suggestive of salmonella. Now, if this were pink, saying that this is urea positive, it would be Proteus. So we use the Kliegler urea to differentiate between our salmonella and our Proteus. Proteus will be urea positive. So these two are used as a screen. Okay? These two biochemicals, Kliegler and urea, they are used as a screen for the non-lactose fermenters.
Question, why is it that we're looking for non-lactose fermenters?
Because salmonella and Shigella are non-lactose fermenters. Alright? Now, once we look at our Kliegler and urea, we are going to go on to further work, depending on what we find here. Now, if the Kliegler had alkaline slant, just a small ring of H2S, a ring of blackening, with no gas pushing out the media, and urea negative, it would be query Salmonella typhi, the typhoid bacillus. All right? If it had alkaline slant, no blackening at all, no gas, and urea negative, it would be suggestive of Shigella. So depending on what we find here, we suspect different organisms. Reporter Polly?
Can you repeat the difference between Shigella and...
No, you're going to get Shigella for the next class. I'm just telling you it will give you a different Kliegler urea reaction. I'm saying that if it's alkaline slant, yellow or acid, with no gas, along with urea negative, it will be suggestive of Shigella. If it had the alkaline slant, a small amount of H2S with acid here, it will be suggestive of what? Salmonella typhi. So depending,
The chart that said little or no gas.
no gas for the H2S, for this typhi, little or no, usually it's no gas.
But if
Most
both
times.
of these have no gas, then what are we supposed to do?
Which one and which one? The Shigella?
If the salmonella and the Shigella, both of them have
Okay.
no gas.
But you would have H2S here, no H2S here.
But it says
Shigella doesn't have
little or
any
no H2S, so it could be
no, no, H2S. Okay, that's why we have to do further work. Now, suppose we got that reaction from a blood culture. It would be more likely Salmonella typhi than Shigella. Shigella is usually confined to the stool. All right? So depending on your diagnosis, if I have a diagnosis of enteric fever, I'm not going to be looking for Shigella. I'm going to be looking for Salmonella typhi. Okay? Now, once we have this reaction, we are going to do a slide agglutination test on the growth that is on here to determine if it is Salmonella or Shigella or whatever else. Now, how do we do the slide agglutination test? We take a glass slide, and you know what a glass slide looks like. We put some saline onto the slide, and we take a small amount of the growth and we emulsify that in the saline, make a suspension, and we add specific anti-serum to that. Now, if you know that Salmonella has an O antigen and an what? What are the two antigens that Salmonella has? H, O and H. O, the somatic, the body antigen. H, the flagella. Because Salmonella is a flagellate organism and the flagella is antigenic. Now we are going to use antibody to the flagella antigen, that's it, the H antibody, and we are going to use antibody to the somatic antigen, the O antigen, both. So we make two suspension on our slide. To one we add the O antibody, to the other the H antibody, and we look for agglutination. If there's agglutination, we are saying that yes, it is Salmonella because it has both the O and the H antigen. So to confirm that, we add some more antibiotics, some more tubes to confirm. You don't have to know these, just that we confirm biochemically. So but you need to know the steps. We isolate the organism on MacConkey and Salmonella Shigella agar. We look for non-lactose fermenting colonies, and we screen using two basic tubes, the Kliegler and the urea. If there's a suspicious Kliegler-urea reaction, we do a slide agglutination to look for the antigens in the bacteria. If they're there, we confirm biochemically, slide agglutination. Now, if we're thinking of S. typhi, Salmonella typhi, we're going to add another one. We're going to look for the Vi antigen, because S. typhi has three antigens: O, somatic, H, flagella, and Vi, which is an extrasomatic antigen that only the S. typhi will have. So we do the same agglutination. And we look for the Vi antigen. All right? That's for the S. typhi. Now for the Shigella, if we had one that we're suspecting Shigella, we are going to do a slide agglutination that has the Shigella antibodies. We have 4 species of Shigella. We have Sunny, we have Boydii, we have Flexneri, and we have Dysentery. 4. So what we'll do, we'll make 4 spots of suspension, and to each we'll add the specific anti-serum. Is that clear? And whichever comes down, that's the one. So that is where we're going to differentiate between Shigella and Salmonella typhi. All right? So that is your step in identifying. First, isolate using the different biochemistry. Then we screen using Kliegler-urea. From here we get an idea of what we have. We do a slide agglutination that will narrow it down, and we do a few more biochemicals to confirm. That's the process. Anything else down there? All right. That is